Material scientists look at a number of different things. They look at all types of design. They look at uses. They look at the structure, the properties of different materials. By looking at these different materials, they decide what they're best used for. Before they do anything getting things onto sale, they have to get them quality tested. This is the bit that you look at with Miss Dave. But essentially, a material scientist is looking to find out what materials we can use and why we should use them. Materials can range from lots of different things. So we're talking about metals, we're talking about ceramics, talking about plastics. There are a whole range of different materials that you need to consider. We're going to split these into two categories, natural and synthetic. Natural substances are things like wool or cotton or silk. A great thing about these natural substances is that they don't need much chemical processing, which means that they don't have any issues in terms of actually getting them ready to be used. Also, another good thing is that they're biodegradable. That means that they will break down and don't last in the atmosphere or in the environment for very long. Also, they absorb water. If you are wearing something that is made of a natural material like wool or silk, by absorbing water it means that it will be more comfortable. However, there are some disadvantages to these natural materials. They're limited. We only have a limited range of natural resources because we only have the ones that actually exist naturally. They also ignite easily, which means that they can set on fire, which of course is a problem if you're wearing them. Also, in terms of clothing, they can shrink in the wash, which means that your top or your item of clothing won't last for very long. If we compare these to synthetic materials, now synthetic materials, what that means is that they are man-made. So man-made materials are things like lycra, polyester, PVC. Again, all materials that can be used to make clothes. And these again have their own advantages and disadvantages. An advantage of these materials is that they're fairly inexpensive to make, which means we can make lots of them and sell them relatively cheaply. They tend to be strong and hard wearing. So you can have that piece of item of clothing and it will last you for a long time. Add to that you can make them any colour that you want. Because they are synthetic, because they're man-made, you can make them depending on what you actually want rather than how they naturally occur. And finally, for clothing, they dry quickly. So when you're washing them, those items of clothing that are made of synthetic materials dry very quickly. So all of those are our advantages of having a synthetic material. However, of course, there are also the disadvantages. The disadvantage here is that they are often come from crude oil, which of course is a non-renewable source, so will eventually run out. They also have a low melting point. Now that means that if the clothes get very hot to the point of their melting point, they can actually stick to the skin. They also produce toxic fumes if they start to burn, and that of course is a disadvantage. They are non-biodegradable. So when somebody gets rid of their clothes, they don't actually biodegrade or break down. They're stuck in the atmosphere, in the environment for a long, long time. And finally, they have limited breathability. They don't absorb water very well. What that means is that if you're wearing them, it can make the wearer quite hot and sticky and uncomfortable. So if we compare that to our natural ones that do absorb the water, they perhaps are not as comfortable. So what do? We met the word composite in last lesson. And composite is where we blend things together. So an ideal blend for clothing would be something like polyester cotton. By combining the polyester and the cotton, you get the benefits and properties of both. Another composite which is used is something called Kevlar. Now, Kevlar is used in bulletproof vests, And it's used in bulletproof vests because it's strong enough that it can withdraw the velocity of a bullet when it hits it. It's made of Kevlar synthetic fibre, and Kevlar synthetic fibre is 5 times stronger than steel. But not just is it 5 times stronger, it's also lighter. So by being lighter, it means that police officers, can wear the Kevlar bulletproof vest, protect themselves from the bullets, but also not actually have anything heavy. In addition to this, going back to our composites, they can make it better by adding a layer of resin-hardened glass, which is a composite itself. By putting a layer of the resin-hardened glass, that means that actually it's stab-proof as well as bulletproof. The final material we're going to talk about on this video is polymers. Now, the word polymer is actually made up of 2 bits. The word poly means many, and mers comes from the Greek word meros, which means parts. So a polymer is something that is made up of many parts, and those parts, as we learned last year, are actually called monomers. So if we have a polymer, it's made up of many parts, lots of monomers joined together. This gives us a very long carbon chain. Within our carbon chain, which is very long, each individual atom is made up of very strong covalent bonds. Now, these strong covalent bonds are difficult to break, so the polymer chain itself is very strong. You may have heard of some polymers. Natural polymers are things like wool and cotton. But there are also synthetic polymers. And synthetic polymers, as we've mentioned previously in this video, are things like PVC, polyester, and nylon. So these are all synthetic, man-made polymers, whereas wool and cotton are natural ones. Now, the good thing about making polymers is that they have some really desirable properties. Remember, we make something new, and our material scientists are constantly trying to make new materials. We want to make them new and useful. So they are flexible. They're not brittle. They can be bent. They have a low density, which means that they are light. And they have low thermal conductivity, meaning that they don't conduct heat very well. So our polymers can be made to have all of these desirable properties. Polymers, things like the plastic covers around plug sockets, are made of polymers so that they don't conduct electricity or heat. That way it's safer. Now, polymers are split into 2 different types. Those polymers are thermoplastic. Thermoplastic is sometimes called thermosoftening. And the other type is thermosetting. Now, these 2 different types of plastics have a different structure. They both have these long chains I spoke about a minute ago, and these long chains are held together by those strong covalent bonds. So the bond itself is strong. But here, the attraction between the layers is very weak. So it's not held together very strongly. That means that thermosoftening plastics are flexible. They can be moulded. They can be remelted and moulded into shape. So our thermosoftening plastics, because they have weak attraction between the layers, don't forget the layers have still got the strong covalent bond. They're flexible and can be moulded into shape. They soften when they're heated. Things like plastic bags are made of thermoplastic, thermosoftening polymers. However, the thermosetting plastics are different. They have something called a cross-link. Now, these cross-links are very strong. Because they are very strong, it means that the plastic is rigid. Think of something that has a hard plastic case. That's a thermosetting polymer. This actually doesn't melt. It decomposes. So it can withhold those slightly higher temperatures, but it can't be remoulded once it's been used once.